this video we have next questions that we can see that I have written here. Next questions, force between two charges in terms of their position vectors. Okay, force between force between two charges in terms of their position vector. Okay, so first you think that positions, okay, in terms of position vectors we have to find out the force, and already we got the force with the help of Coulomb's law. What is the formula of Coulomb's law? Simple things are, you will say F equal to 1 by 4 pi epsilon naught q1 q2 by r square. Okay, this is correct. In the vector forms we have taken the vectors and also we have multiplied with the unit vector. Okay, because that gives the directions. Now you see that I have taken here the coordinates. In class 11 already you have studied the coordinates, okay, in first units that you had, okay, I think that second units, no, motion chapters, already you have discussed motion in your plane. Okay, so you see that now I have here coordinate x, y and z. This is the axis, x axis, y axis, and this is the z axis, who is the origin. Okay, here's two charges q1 and q2 I have taken here. See, one is q1, next is the q2. q1 is placed at point A and q2 is placed at point B, and both having distance r. Okay, and here vector r1 and r2 is the position vector. What is vector r1 and r2? Position vector. I will write also here. Okay, r1 and r2 position, these represent position vectors. R is the distance between A and B in which the q1 charge placed and q2. Okay, what is F12? Force experienced by charge q1 due to q2, and similarly F21, that you can also write force experienced by q2 due to q1. Okay, very good. So already you know that before deriving we have to write the theoretical part. So assume, you can assume, okay, let us consider a coordinate frame OXYZ in which two charges q1 and q2 placed which having position vector r1 and vector r2. Okay, correct, this we can write at least. And you know that this you can also represent here q1 q2 already I have told. Okay, so according to Coulomb's law, what we can write? According to Coulomb's law, according to Coulomb's law, we can write F12 also, we can give the numbering here. F12, what you will write? Vector F12 equal to 1 by 4 pi epsilon naught q1 q2, okay, q1 q2 by r square. And you know that in the Coulomb's law in vector forms we also give the, okay, unit vector. So what is that? If you will take here, this is the r, r is the distance, so you can write here r21 here, and if you will give the direction here, so then here will be r12. Okay, so you can give here r21. Similarly you can write F21 equal to 1 by 4 pi epsilon naught q1 q2 by r square, and here will be cap of r12. Okay, very good, this we can write. So we got these two formula F12 and F21 like that. but you know that here is in which shape? This is like as a triangle, and you know that in vector chapters you have okay studied that the triangle of addition of vectors. Okay, very good. So sum of this and this, because the direction is here from this side, so OB plus BA equal to OB, because according to directions we have to add. Okay, so you can write here now according to triangle law. Okay, according to triangle law of addition of vectors, what you will write? You will write, you see the diagrams, you will write here OB, vectors OB, yes, plus BA equal to OA. This we can write. Okay, very good. But we have to find out the value of OB. Which one? This value you have to find. Sorry, this BA, this one BA. So you can write next side. So or you can write vector BA equal to OA minus OB. Can we write like that? Okay. And we have value. What is the value of BA? Here is R. Okay. So this you can also write. Can we write like that? Okay, very good. R, and here is unit, that you can also write, no problems. So here will be R and R21. Very good. Cap of R21 equal to OA. OA, what is the value? O to A. Here is R1 and here is R2. Very good. So you can write here R1, here in vector form you will write, and here will also R2. Okay, so this value you can use. And one more, if you will remove this, then here will be mod. Okay, so you can write here, or you can write R equal to vector R1 minus R2, and here will be mod. Okay, so these two you can put here. You can put here. Okay, so you can put here equation 1. This is the equation 2. So from equation 1 and 2. Okay, and also one more, you know that you can, I think that better you can multiply and divide here also by R, because if you will remove this one on that times we can, okay, no problems. So from equation first what we can write? From first equation, yes, one F12 equal to 1 by 4 pi epsilon naught Q1 Q2 by R square and R2 1 cap of. Now here we can multiply and divide. Okay, now multiplying and dividing by R on RHS, only on RHS sides. Okay, so you will write here, this we can remove now, this, okay, because there is less space, so we can remove these ones. Okay, multiply, then here will be F12 equal to 1 by 4 pi epsilon naught Q1 Q2 by, what you will write, RQ, and here will also R and R2 1. Very good. Okay, or you put this value, these ones and this one put here, or you can write F12 equal to 1 by 4 pi epsilon naught Q1 Q2 by, at the place of R. What is the value of R? See here, mod of vector R1. Yes, R1 minus R2, it is in mod. And what is the power? Here is 3, so you can give 3. Okay, and this value you have, what is the value? R1, vector R1 minus vector R2. Okay, so you got one value. And also from equation second, similarly Similarly, from equation 2, this equation we can use F21 equal to 1 by 4 pi epsilon naught Q1 Q2 by RQ here will also. Okay, so directly can we write or one more step? No problems. R and R1 2 it will be in cap. So R you can put these ones. So vector F21 equal to 1 by 4 pi epsilon naught Q1 Q2 at the place here will same, but the numbering will change. No, yes, very good. So here will numbering change. So because here is 2 R1 minus vector R1 minus R2, but here will be vector R2 minus vector R1 mod of, and power will remain same, and here it will also change. Here is 1, so here will be 2. Okay, vector 2 minus 1, like that. So this is the formula that we got with the help of Coulomb's law. Okay, in vector forms. Okay, with the help of Coulomb's law in vector forms, we got these two equations, and by using the triangle law of addition of vectors, okay, OB plus BA equal to OA, and we have to find this value. So you can write next side. So here will be minus because sign will change. Okay, and put this value. Okay, with the help of diagram, this value is vector R1, here R2, and here is R and cap of R2. Okay, so this, if you will remove this one, then here will be in mod. So this value and this value we can put here and here, but before it we have we can also multiply with R on RHS, and also we can divide these ones. Okay, so these two value we got. So you can write this one, force between two charges in terms of their position vectors. Okay, I think that you may have written these ones. Okay, very good. Okay students, so next class we will discuss more topics. Okay, thank you.